The diagram shows the vertical cross-section OAB of a slide. The straight line AB is tangent to the curve OA at A. The line AB is inclined to at alpha to the horizontal, where sine alpha is equals to this. Okay. The point O is 10 meter higher than B. AB has length 10 meters. The part of the slide containing the curve OA is smooth, and the part of the slide containing AB is rough. Okay. If this is rough, that means we'll be using mu r, and we will be using cos alpha as well. So let's find cos alpha from sine alpha. Okay, sine alpha is given as 0.28. I need cos alpha, so I can use trigonometry formula. Sine square alpha plus cos square alpha equals 1. So 1 minus sine square alpha square root should give us the value of cos alpha. So 1 minus 0.28 squared, and then square root that, 0.96. So cos alpha is 0.96. Let me write it here. Cos alpha is 0.96. Okay. A particle P of mass 2 kg is released from rest at O and moves down the slide. Find the speed of P when it passes through A. Okay, so we need the speed here, and we know the speed here is 0. Okay, we cannot use equations of motion, remember, because it's not a straight line. Okay, so I'm going to use the energy formula, which is work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. There's no driving force in this question. There's no power, no engine. It's just a particle. Okay. Now loss in energy. So as the particle comes from this point to this point, the potential energy decreases. And the formula for potential energy is mgh, where h is the difference of height. So we need this height. Okay. How would we find this height? Let's find this height first and then subtract it from 10. This would be 10 sine alpha. So 10 times 0.28, which is 2.8. So the rest of the height would be 10 minus 2.8, which is 7.2. So I'm using mgh as loss of energy. M is 2, G is 10, and height is 7.2, is equals to work done by resisting force. There's no resistance from A to B, from O to A, sorry, plus gain in energy. So gain in energy is the gain in kinetic energy, which will be half times M times bracket bigger speed square minus smaller speed square. Bigger speed would be V, smaller speed is 0. Okay, solve this and get the value of V. This comes out to be 12. Okay. Part 2 says the coefficient of friction between P and the part of the slide containing AB is 1 by 12. Find the acceleration of P when it is moving from A to B. Okay. So if we need acceleration, I'm using Newton's second law. Forward force minus backward force is equals to MA on this part of the journey. Okay. So if I draw the particle slightly above here, for clarity. So this downward force will be mg sine theta. This would be r. This would be mg cos theta, the component of it. And this would be mu r. So I'm using forward force, which is mg sine theta, minus backward force, which is mu r, is equals to ma. Okay. M is 2, G is 10, sine theta is 0.28, minus mu is 1 by 12. R is, this is R, and opposite to that is mg cos theta. Let's use that. Times mg cos theta, which is 0.96, is equals to 2 times A. Solve this and get the value of A. It comes out to be 2. A is equals to 2 meters per second square. Okay, next part is find the speed of P when it reaches B. Okay. Now for this part of the journey, since it's a straight line and there's again no driving force, so we can use equations of motion. We know that U is 0. Sorry, no, from A to B, U is not 0. U is 12, this U. S is 10. A just came out to be 2. And now we need V. So we can use V square equals U square plus 2AS. And then to find the value of V, we square root this. 12 square plus 2 times 2 times 10. This comes out to be 13.56 something, 13.6 meters per second.